In this video, we'll cover the basics of ASCII, Unicode, and UTF-8. Starting with ASCII. ASCII is a character encoding. It maps some bits, zeros and ones, into characters. And as we know, computers store everything as zeros and ones. That's why it's needed. ASCII uses 7 bits for encoding, meaning that there are 2 to the 7, which is 128, different characters that can be represented. So here's an example. 65 represents A, 116 represents T. And note that the case matters here. Now in binary, this is how it would look. Now there are some drawbacks of ASCII. The original 7 bits were only enough to represent English characters and punctuation, and maybe some codes. And because a byte is 8 bits, there was a lot of competition on which other characters should be supported with that last bit. Now enter Unicode. Unicode is a universal character encoding. It supports many different alphabets and even emojis. However, unlike ASCII, Unicode does not define how its mapping should be implemented. And we'll get into the details of that in a little bit. It only specifies which character refers to which code point. And a code point is a hexadecimal number representing a character. For example, U plus 0041, note that that's hexadecimal, represents A. And 0041 hexadecimal is actually equal to 65 in decimal. Now enter UTF-8. UTF stands for Unicode Transformation Format. It is an algorithmic mapping from every Unicode code point to a unique byte sequence. UTF-8 is nice because it has variable length encoding. This means characters with code points with small values like A can be represented with just 1 byte, and characters with code points with large values can be represented with more bytes as needed, and it goes up to 4 bytes. Another nice property of UTF-8 is that it's backwards compatible with ASCII. This means that any ASCII file can also be read with UTF-8. Note that this is true with UTF-32 as well, but not for UTF-16. But we won't get into that here. Because of these 2 nice features, UTF-8 is now the most dominant encoding for the World Wide Web and accounts for roughly 98% of all web pages. So we can see here the characters on the left, the code points in the middle, and the UTF-8 binary encodings on the right. We can see that the character A has a code point of U plus 0041, note that's hexadecimal, and here is the binary encoding. Now this is a Chinese character on the very bottom. It has a much larger code point. This is a much larger hex value, and therefore it needs 4 bytes to be represented in binary. So here's a summary. ASCII was the first major encoding. Because of computer limitations, it was only 1 byte. Unicode was invented to address the problem of encoding more languages than just English. And UTF-8 is a